There are some other objects that we can find out the surface area for that we'll be covering this year, so let's list some of these out. The first of these is the cube, and a cube is basically a rectangular prism where every single side is a square, and if I call one of those sides S, and I go about doing what I did last day, which is thinking about area 1. Oh wait, this is also area 1, and so is this, and so is the one on the back, and so is the one on this side. And, oops, I wrote area 2. Area 1 on that side, and area 1 on the bottom as well. So when I go about calculating the surface area for this, I have 6 area number 1s, and area 1, each one is a little square, and the area of a single square is s times s, so s squared, so it's 6s squared. And we can use that sort of process to calculate the surface area formula, if you like to use formulas. You don't have to memorize these formulas, you can just go through the calculation each time for a bunch of other shapes as well. So let's take a look at a second shape, and that's the rectangular prism. And so a rectangular prism, that's a rectangle, and there's my prism, and we've got the length and the width and the height. And so when you start calculating these areas, you got an area 1 on the front and the back that are the same. You've got an area 2, say on the top and on the bottom that are the same, and an area 3 on those end parts that are the same. And so your surface area formula is there's 2 area 1s and 2 area 2s and 2 area 3s. And to actually calculate one of those, we'll take this front face for an example. That front face is length times height. So you have 2 length times heights, and the A2s on the top are length times widths, and the A3s on the end are height times width, or width times height. So there's a surface area, and 2 of those. There's a surface area formula. And again, you don't need to know these formulas, you need to know the process of making the formulas, because I probably won't even give you a rectangular prism. I'm going to give you some fairly complicated shapes this year, and we need the process rather than the actual formulas to be able to generate solutions. Here's the third shape that we'll take a look at. It's a triangular prism. And a triangular prism is, of course, made up of a triangle, and I'll make this a right triangle just so we can do some little bit more interesting things. I'll call this B across here, and height H, and then I'll extend this triangle off into space. Kind of draw it in 3D for you like that, and that'll be the width across there. And so surface area, well, I've got a front triangle here. I'll call that area 1, and there's another area 1 on the back. That's the triangle on the back side. And then I've got a rectangle on this side. I'll call that area 2, and a rectangle on the top. That's area 3. And then a slopey rectangle on this side. That's area 4. So the surface area is just add those things up. 2 area 1s, an area 2, an area 3, and an area 4. Notice those rectangles, area 2, 3, and 4, are all different. And that they're not necessarily all different, but be careful with that, because same with the rectangle. Some people will just assume like area 1 and area 2 are the same. They're not necessarily the same. They're not necessarily different, but you do need to be aware of what sides are the same, exactly the same. And you can't always trust the pictures either. You need to trust the numbers. Let's take a look at this formula in a little bit more detail. So area 1 is a triangle, and to calculate the area of any triangle, it's half the base times the height. And I know the base and I know the height. So really I have 2 half base times heights, and 2 times a half is just base times height. And then for area 2, which is over on this side here, I know it's h for height and w for width. So width times height. Area 3 is base and width. So base times width. And then area 4 is the really tricky one. Area 4 has whatever length this is, and then a width. And I can calculate that length. All I need to do is, give myself a little bit more room for this, all I need to know is how long is this missing side here. And because this is a right angled triangle that I happened to do for this case, I can use Pythagoras. So h squared and b squared would be that missing side. I'll call it x squared. And if I wanted to know just what x is, I'd have to take the square root of whatever h squared and b squared was. And so that missing side is that length of that rectangle, and then there's a width to that rectangle. So I've got width times height and base times width, and then this last one is width times x, so I'll just say wx, but now I know what that x is worth. If I do Pythagoras, it's width times the square root of h squared plus b squared. I know that might seem complicated. That's actually just the shortcut. When I calculate these things, I actually go through doing the Pythagorean theorem. I find that really useful and really helpful to do. It also reminds me how to do Pythagoras every single time. Okay, the fourth shape that we need to be able to do is called a cylinder, so let's take a look at that one next. And a cylinder has a circle on the top and a circle on the bottom, and what you really need to know about a circle is the radius and the height. And calculating the surface area is a little bit tricky. You've got a top and a bottom that are the same, so two area 1s, and then you've got this weird side piece. It's like the label of a can, and we'll call that area 2. And area 1, if you looked at the top, area 1 is a circle of radius r, and the formula for the area of a circle is pi r squared. So I have two pi r squareds, one for the top, one for the bottom, and then I have area 2, and area 2 is this weird label piece. Well, actually, if you were to cut this label down here and unwrap it, it would actually look like a rectangle. The top part would wrap around the top of this circle. So that would wrap all the way around the circle, and so it has to have the same distance as the circumference, and the circumference is 2 times pi times r for any circle. And then this label would be the same as this, which is the height. So knowing how to calculate the area of a rectangle, which is length times width, I have 2 pi r as one of my direct dimensions, and h is my other dimension. So a shortcut for the cylinders is to use the formula. The surface area is two circles, 2 pi r squareds, plus 2 pi r h.